Okay, today we are going to finish up talking about complex numbers and some more arithmetic that we can do. So yesterday we learned to add, subtract, and multiply with our complex and imaginary numbers. Today we're going to talk about how to divide and take their absolute value. And this is the last lesson of the middle section of our quadratics unit where we're talking about these skills. So tomorrow we will review these skills, and then on Thursday we'll have a quiz over this stuff. So to divide two complex numbers, we're going to have one complex number, a plus bi, over another complex number, a plus bi. Our goal is that we want one single a plus bi as our answer. And unfortunately, it's just not as straightforward as just divide the real parts and divide the imaginary parts. That's not how dividing numbers works. So what we want to do is get rid of having an imaginary on the bottom. To do that, we are going to choose to multiply by something that is called the conjugate. The conjugate has the same numbers, but the opposite sign in front of the I part. So yesterday in a couple of our examples, this happened, where all we were asked to do was to multiply two things that had the same numbers, but the opposite sign in front of the I. And when we did that, we saw that we ended up with a real number. So that's going to be our first step, is to multiply by this conjugate. Same numbers, but opposite sign with the imaginary. But I can't just multiply the bottom of the fraction by something because that changes its value. So I have to multiply the top by the same thing, because then really I'm just multiplying by what? By 1. So yesterday we learned to multiply, so now we're going to multiply these together, foiling the way that we learned to yesterday. So I pass out the 5, and I get 5 plus 10i, and then I pass out the 3i, and I get 3i plus 6i squared on the top. And then multiply out the bottom. Get 1 plus 2i minus 2i minus 4i squared.
Is it always 1 plus 2i?
It's always the same numbers as the bottom,
Oh.
but just switch the sign. So whatever the bottom numbers are, we use those numbers and then just switch the sign. Now we're going to clean these up like we did yesterday, and remember to change that I squared into a -1. So on the top, this I squared being a -1 really just turns this into a -6, because I squared is a -1, which just changes the sign. So it really just turns this guy into a -6, which means on the top I have a -1 plus 13i. On the bottom, having an I squared really just changes the sign, so it's going to become a plus 4. So I can put that together with the 1 and make 5, and then notice what happens to the i's. 2i and -2i, they cancel each other out. That should happen every single time. That's why we're multiplying by what we're multiplying by, is so that that will happen, so that those imaginaries will disappear. We want our final answer to be a plus bi, so our last step is just to take this 5 that's on the bottom and divide it into each part of the top individually. So our final answer is going to be -1/5 plus 13/5 I. So we just take that 5 that's on the bottom and divide it into both numbers on the top individually. We're going to do several more examples of this, but are there any questions before we start our next one? There are probably questions, but as we do more, hopefully they'll become a little bit more clear.
Do you always multiply by the bottom, but you like change the sign?
Yeah, we always use what's on the bottom and then just change the sign of the I part. Okay, so in this one, what are we going to multiply by? 1 minus I. Same numbers as the bottom, but just change the sign with the I. I have to multiply the top by the exact same thing so that I'm really just multiplying by 1. So then on the top, we do our distributing. Pass out the 2, and I get 2 minus 2i. Pass out the negative 7i, and be careful when you do this. I'm passing out a negative 7i, so I get negative 7i plus 7i squared. Always make sure you attach a number to what's following it. So I'm passing out a negative 7i, which is going to change the signs of that second group. Then on the bottom, I pass out a 1, 1 minus I, and pass out an I. So I get plus I minus I squared. Questions so far? So then to clean these up, an I squared is a negative 1, so that's going to change this to a minus 7 on the top, which gives me then negative 5 minus 9i. And that I squared on the bottom is going to change this to a positive 1, so I get 2. And the i's cancel out. And the final step is to clean it up so that it's an a plus bi by taking that 2 that's on the bottom and dividing it into each part of the top. So I get negative 5 over 2 minus 9 over 2 times I.
What determines the sign between the fractions? Like the negative or positive?
Between the fractions?
Like 5 over 2 minus 9.
Oh, whatever the signs of the numbers are. So since the 5 was a negative, it stays negative. The 9 was a negative, so it stays negative. What am I going to multiply by in this one?
Negative 1 plus 2i.
Negative 1 plus 2i. Good job. We only want to change the sign on the I part. On the other examples, I never have students tell me to make the first number negative, but on this example, students will often want to change that negative 1 into a positive 1 as well. We only want to change the sign on the I. Okay, it's just the sign on the I that changes. And multiply by the same thing on the top, so we're really just multiplying by 1. In the top, I pass out the 3, negative 3 plus 6i. I pass out the 11i, negative 11i plus 22i squared. In the bottom, pass out a negative 1. Again, be careful, you're passing out a negative 1, so I get positive 1 minus 2i. And then pass out a negative 2i, so I get plus 2i minus 4i squared. Be really careful with those signs when you're distributing. Questions so far? We want to clean it up by changing an I squared to a negative 1, which makes us a negative 22 on top. So I get negative 25 minus 5i. On the bottom, the I squared changes to a plus 4 at the end. So I get 5, and the 2i and negative 2i cancel. And for our final answer, we divide the 5 into both parts of the top. So negative 25 over 5 and negative 5 over 5i. If they can be reduced, you should reduce them. So our previous answers, the fractions couldn't be reduced, but these we can actually reduce down and say that it's -5 minus I or minus 1I. So if you can reduce your fractions, you should reduce them. Okay, and it might be possible that you could reduce one fraction but not the other one. You should still reduce what you can reduce. Questions? What am I going to multiply by?
Positive 5 plus 2i.
5 plus 2i. So same numbers as the bottom, change the sign of the I part. What am I going to multiply the top by?
Same thing.
Same thing, so that I'm really just multiplying by 1. So on the top, pass out the 5, 25 plus 10i. Pass out the 2i, 10i plus 4i squared. On the bottom, pass out the 5, 25 plus 10i. And pass out the negative 2i. Make sure you're passing out that negative. So you get negative 10i minus 4i squared. On the bottom, you know that the I term should always end up disappearing. So if you want to just skip that part of the distributing, that's okay, because it should happen every single time anyway. If you want to do it so that you can confirm it's actually happening and help you know that it's going correctly, that's fine. But if you want to just kind of save some of the writing, you can skip those outsides and insides because they're always just going to end up canceling each other out. That's why we're multiplying by what we're multiplying by. And I squared becomes a -1, so on the top that changes to a -4 at the end. So that gives us 21 plus 20i. On the bottom, I squared changes it to a +4, so I get a 29. And final answer, divide that 29 into both parts of the top. Questions? Absolute value. Earlier this year when we talked about absolute value, I defined absolute value for you, and I said it's really not just make it positive, which a lot of students say that's what an absolute value is. What did I say absolute value was? The distance from 0. Absolute value is distance from 0. So when we're talking about real numbers, we're looking at a number line. And in effect, it is just make it positive because 3 is 3 units away from 0. -3 is also 3 units away from 0. So when we're working with real numbers, an absolute value really does just make it positive. But once we get into complex numbers, we can't just make it positive. Okay? Absolute value means a distance. So what we're going to do to find an absolute value of a complex number is we're going to plot it on what we call the complex plane, which is where we say that our x-axis is our real axis and our y-axis is our imaginary axis. And we're going to plot out this number. So this number has a real part of 3 and an imaginary part of 4. So I'm going to go over 3 on the real, up 4 on the imaginary, and plot that point. Some of your homework problems will ask you to just plot the imaginary number. So then this would be it, and you would be done. Okay? So to plot an imaginary number, we go on the x-axis, the real amount, on the y-axis, the imaginary amount. To find an absolute value, what we're going to do is connect that dot to the origin and close it off with the x-axis to make a triangle, which happens to be a right triangle. Then we're going to fill in the lengths of the sides. So on the real axis, we had gone over 3. On the imaginary axis, we had gone up 4. Then step 3 says we are going to use our Pythagorean theorem to find that hypotenuse, which is how far that point is away from the origin, or away from 0, 0. So that would be the distance or the absolute value that we're looking for. So the Pythagorean theorem is c squared equals a squared plus b squared. So we do c squared equals 3 squared plus 4 squared. C squared is 9 plus 16, which is 25. And take a square root, and we get 5. So the absolute value of 3 plus 4i is 5. The absolute value of a complex number is just a real number. There should be no imaginary part of it. Okay? It's how far that point is away from the origin when plotted as a real and an imaginary number. Okay? Questions? Yes?
When you drew in the lines in the triangle, do you always put it at 0? Like connecting right there?
Always connect it to 0, 0. Yeah, because that's the distance that we're trying to find, is how far is it from the origin. So for this one, I'm going to start by plotting it. So I'm going to go -1 on the real, up 5 on the imaginary. Connect to the x-axis, and connect to the origin, and I get a really skinny little triangle. I'm going to fill in the sides of the triangle. You don't really need to worry about negatives here because we're talking about distances. So I can just say that that side is 1, and that side is 5. So the distance that we're looking for is c squared equals 1 squared plus 5 squared. So that's 1 plus 25, which is 26. And we'll take a square root of both sides. Simplify square roots when possible. So a few days back, we learned how to simplify square roots. When we simplify a square root, we're looking for a perfect square that divides into this number. Are there any perfect squares that divide into 26?
No.
26 is 2 times 13. There's no other way to divide it up, and those aren't perfect squares, so this one is done. But if your square root can simplify, it should be simplified. How do I plot this number?
0 minus 2i.
It's 0 minus 2i. So I go over 0 on the real and go down 2 on the imaginary, and here's the point. Then I want to connect that point to the origin and to the x-axis, which is the same thing. So how far is that point away from the origin? 2 units. So if our number is just real or just imaginary, then absolute value really is kind of just make it positive, except we don't want any i's in our answer. We just make its coefficient positive. But if our number is complex in that it has both a real and an imaginary part, then we need to do our Pythagorean theorem. But if we plot out just a real number or just an imaginary number on one of the axes, then it's just how far is it away from the origin, and we can count that out. So for this one, to plot it out, I'm going to go over 5 and down 3. Connect to origin, connect to x-axis. I have sides of 5 and 3. You don't really need to worry about the negative because we're talking about distances. We're going to end up squaring it in our equation anyway. So c squared is 5 squared plus 3 squared. And it's 25 plus 9, which is 34. Take a square root and simplify if possible. Are there any perfect squares that divide into 34? It's 2 times 17, and those are both prime, so it's not going anywhere, and it's just square root of 34. But if it can be simplified, it should be simplified. Questions? Your homework's from 5.4 again. Same section as last night, just different numbers.